All right, welcome to The Explainer. Today, we're diving into a new AI model that's, it's not here to write your emails or generate a cool new profile picture. No, this one was built with a much bigger mission in mind, to tackle some of the hardest problems in science. You know, we hear all the time about how great AI is at everyday stuff, right? Writing emails, making art, it's impressive. But let's be honest, that's not the grand promise we were all sold on. We were told AI would help cure diseases, solve climate change, unlock the secrets of the universe. So the big question is AI actually living up to that promise? Or is it kind of failing its most important test? So let's get right into it. There's this really interesting, kind of surprising problem popping up in the world of AI. It turns out that while these models are getting incredibly smart at, general stuff, they really start to struggle. I mean, they basically hit a wall when you ask them to do real complex science. I mean, don't get me wrong, the progress has been insane. The open source models, the ones any researcher can access, are catching up fast to the big players like GPT-4 for things like writing code or summarizing a report. But the moment you pivot to something really scientific, like analyzing a protein or predicting a chemical reaction, suddenly that gap isn't a gap anymore, it's a canyon. And that's a huge problem because it means the best tools for science aren't actually available to most scientists.
And check out this trend, because this is what's really wild. As the general smarts of these AI models go through the roof, their ability to handle science has just stalled. It's totally flatlined. It's like we've created this brilliant, articulate genius who can talk about anything, except they're completely fluent in every language but the language of science.
And look, this isn't just some academic debate about who has the highest score on a benchmark test. The folks behind the model we're talking about today put it perfectly. This gap has real, tangible consequences. It's a bottleneck. It's slowing down actual progress in medicine, in material science, in everything that really matters. Okay, but here's where things get exciting. A new contender has stepped into the ring, one that was designed from the ground up, from its very first line of code, to bridge this exact gap. Its name is Intern S1. Now, the team calls Intern S1 a specialized generalist, which is a really cool way to put it. Think of it this way. It has all the broad knowledge and reasoning power of a big, general-purpose AI, but it's also been meticulously engineered to be an absolute expert in the specific areas of science where all the other models just throw up their hands. And the proof is in the pudding, right? Look at these results. On a whole battery of really tough scientific benchmarks, Intern S1 doesn't just beat the other open-source models, it blows past even the top proprietary closed-source models. This is a whole new ballgame for AI in science. So, the big question is, how do they do it? What's the secret sauce here? Well, it really boils down to three core innovations, and the first one is all about what they fed it. It's data diet. Yeah, if you want to create an AI that's a genius in science, you can't just let it browse the internet. You have to give it a library card to the world's greatest scientific library. Intern S1 was trained on an absolutely mind-boggling amount of specialized data. We're talking over 2.5 trillion scientific tokens. Just try to wrap your head around that number. It's a staggering volume of pure scientific knowledge. And it wasn't just a case of throwing every science textbook into a blender. No, this was a carefully prepared gourmet meal of data. It was meticulously balanced across all the key scientific fields. You've got life sciences, physical sciences, chemistry, physics, math, the whole shebang. Now, here's the tricky part. Getting your hands on this kind of high-quality science data is hard. A lot of it is buried in dense PDFs with weird formatting, or it's just a tiny needle in the giant haystack of the internet. So what did the team do? They basically built their own team of AI agents to go on a treasure hunt, smartly digging through scientific papers, pulling out text, formulas, and even images, and then filtering massive web datasets to jack up the science content from a tiny 2% to over 50%. It's pretty brilliant. Okay, so you've got this amazing library, but that's only half the battle, right? You also need a brain that can actually understand everything in it. That brings us to pillar number 2. Intern S1's unique architecture. It's what they call a multimodal mind, and it goes way beyond just reading text. So at its heart, it's a super powerful language model, like the ones we're used to. But, and this is the key, it's been given a bunch of specialized tools. You can almost think of them as different sets of eyes. It has one pair for reading text, another for looking at images, another for interpreting signals. Each one is custom built for a specific type of scientific data.
So what does that actually mean? It means this AI can look at a picture of a really complex molecule, and it reads it, it understands it, just as easily as you and I are understanding these words. It is literally fluent in the visual language of chemistry.
And it's not just static images. It can take raw, squiggly line data, like the output from a seismograph during an earthquake or an EEG of brainwaves, and it can make sense of it. To most language models, that's just random noise. To Intern S1, it's information it can analyze and reason about. A huge piece of this magic is something they call a dynamic tokenizer. Okay, here's the best way to think about it. Most AIs have like one wrench they use for every single job. It's a one-size-fits-all approach. InternSen, on the other hand, has a massive specialized toolbox. When it's reading plain English, it pulls out the English wrench. But the second it sees a chemical formula written in Smiles code, it swaps it out for a custom-built Smiles wrench. It always uses the right tool for the job. And why does this matter? Well, because using the right tool is way more efficient. The end result is a staggering 70% boost in data compression efficiency. That means it can process way more information, way faster, using way less computing power. It's a massive performance upgrade across the board. Okay, so we've got the world's best library, and we've got a super brain to read it. That brings us to the third and final pillar, the training. How do you actually teach an AI to not just know science, but to think like a scientist? For this, they used a super advanced technique called mixture of rewards, or MA. You know how you train a dog with treats for doing the right thing? It's kind of like that, but on an insane scale. Instead of teaching it one trick at a time, Ma gives it feedback like a reward signal from over 1,000 different scientific tasks all at the same time. It learns how to be an expert chemist, physicist, and biologist all at once. And just like with its tokenizer, this training method is incredibly efficient. So efficient, in fact, that it allowed Intern S1 to hit that top of the class state-of-the-art performance level while using 10 times less training time than other cutting-edge models. That's a huge deal. So let's just pull this all together. What makes Intern S1 such a potential game changer? First, it finally starts to close that massive science gap in AI. It does this with 1, a massive hand-picked diet of scientific data. 2, a multimodal mind that can read way more than just text. And 3, a super efficient training method that makes it incredibly powerful. But here's the real kicker, the thing that might matter most of all. Intern S1 is open source. That means this incredibly powerful tool isn't locked away in some corporate vault. It's being given to the entire scientific community. It completely levels the playing field and could light a fire under the pace of discovery for everyone. And that really leaves us with one last kind of awe-inspiring question to think about. What happens next? What happens when every single scientist in every lab, everywhere in the world, gets a super intelligent research assistant? What breakthroughs are waiting just around the corner?